Since the question says the eigenvalue lambda and the corresponding eigenvector u. So lambda is the eigenvalue and u is the eigenvector for the matrix A is given by which of the following options. So we have to find the eigenvalue and eigenvectors of this matrix. The matrix is 2 minus 1 minus 2 3. Now let's first find the eigenvalue of this matrix. So characteristic equation is 2 minus lambda minus 1 minus 2 3 minus lambda this equal to 0. So that means from here we get 2 minus lambda into 3 minus lambda minus 2 equal to 0 implies 6 minus 5 lambda plus lambda square minus 2 equal to 3 implies lambda square minus 5 lambda plus 4 equal to 0. From solving here we will get lambda equal to 4 equal to plus 1. So these two are eigenvalues of the given matrix, and corresponding to these two eigenvalues we will find the eigenvectors. First eigenvalue is 4. So let's try to find the eigenvector of the eigenvector corresponding to the eigenvalue 4. Suppose x1 is the eigenvector. So that means ax1 equal to lambda 1 x1. So we will get 2 minus 1 minus 2 3. x1 will be x1 x2 suppose. That will be 4 x1 x2. So from here we will get two equations. So we will get 2x1 minus x2 and minus 2x1 3x plus 3x2 equal to 4x1 and 4x2. So comparing both sides we can get from here 2x1 minus x2 equal to 4x1. So that means we will get x2 equal to minus 2x1. So the corresponding eigenvector is x1 x2. So x1 will be there and x2 is minus x1. So if you take x1 outside you will get 1 minus 2. So 1 minus 2 is the eigenvector corresponding to, so this 1 minus 2 is the eigenvector corresponding to the eigenvalue lambda 1 equal to 4. For the second eigenvalue lambda 2 equal to 1, and suppose x2 is the eigenvector here. So from this ax2 equal to lambda 2 x2. So that means 2 minus 1 minus 2 3 into x2 means x1 x2 equal to 1 into x1 x2. So we will have here 2 x1 minus x2 minus 2x1 plus 3x2 equal to x1 x2. From here we will get 2x1 minus x2 equal to x1. So that means we will get x1 equal to x2. So corresponding eigenvector equal to x1 x2. So x1 we will put x1 here. We will get x1 1 comma 1 1 1. So this 1 1 is the eigenvector corresponding to the eigenvalue lambda 2 equal to 1.